So now we want to get back towards the graphical or the visual interpretation of the mod function, play around with a little bit, shift it up, down, left and right, and see what happens and what regions are created, and maybe what new questions I can throw around that. And then again a little more, I mean, it sounds like a lot of build up, but then finally getting to working with graphs to solve that mod minus mod story as well. But that is a few steps ahead. Right now I want to start with the very simple interpretation of the most basic mod function. Again, some of you might remember it from the first session on the overall graphs and slopes, etc., which is important. You need to understand how slopes work because I will be using that story here, right? So comfort with slopes and basic equations of line, etc., will definitely be helpful, but we'll go step by step, reveal everything in quite a lot of detail, so nothing to be concerned about, right? So y is equal to mod of x. You can also call it is equal to function of x, right? So we should be okay with various interpretations. So that's why we started the algebra journey with just input and output. What is input? What is output? What is the relationship between x and y? So for starters, I just want to think in numbers. When x is 0, what is the value of y? If you put x is 0, you will get the value of y as 0. If you put x as 1, you will get the value of y as 1. I suggest if you're a beginner and you're not very comfortable with maths, try and do this for 5 more steps till you see a pattern, and you will say, okay, whatever is the value of y is the value of whatever is the value of x is the value of y. It's a very simple relationship. But are we done? No. The whole story of mod lies in what happens in the positive region and what happens in the negative region, right? So let me also think of what happens at x is equal to minus 1. If I put a minus 1 here, right, I just know the mod will convert it into a plus 1. I know that much at least by now already. So y will still be 1. What happens when x is minus 2? Y will be equal to 2. What happens when x is minus 10? Y will be equal to minus 10, right? So I should be clear about when I say table or input output, I should be clear that this is what I mean. I can always make a table and just write all the details, right? And that is my beginner level starting point. Now I want to capture this information on my coordinate axis, right? So this is the x axis and this is the y axis, right? What is this point? This is the 0, 0 point. This is what is known as the origin. Okay. X is equal to 0, y is equal to 0. That means this is a point. X is equal to 1, y is equal to 1. At 1, 1. Again, I am not using accurate graph paper, but I hope you do at least once. Either you did it a lot in school, or why not buy or make a screenshot of a graph paper and plot this graph a few times. In 5, 6, 7, 8, 10 steps, you'll be very, very clear about what is happening, right? So at 1, y will be 1, 1, and then I will assume that you're all adults, and if you keep plotting it, you will get such a line. By the way, this is nothing but y is equal to x, right? So a line appears. The line starts at this point and it keeps going up. If x is 100, y will be 100. It's a straight line. You should also think of the slope. What is the slope? This point was 0, 0, and the next point was 1, 1. So x changes by 1 and y also changes by 1. So the change in y upon change in x is equal to the slope. So, or how many units does the y or the output change by when I change the input by 1 unit? Again, if this sounds uncomfortable or unfamiliar, please revisit the chapter on slopes and basically dealing with lines as such, right? But just an intro in terms of what is going to happen in the next few steps or sessions, right? Now let me think. Now I've extended the logic. Now let me think of the negative domain. When x is minus 1, y is equal to 1. When x is minus 1, y is 1 positive. Anything above the x-axis, the value of y is positive. Anything below the x-axis, the value of y is negative. Y is never going to be negative because this is a simple mod function. At minus 1, the value is 1. So my line will go something like this. At x is equal to minus 2, the value is going to be 2. The y's value is going to be 2. So this will be my graph. So next time if I just say mod of x is like this, I should know that I'm talking about this function. So this line was y is equal to x. What is this line? This line is y equal to minus of x. Where is this coming from? Because remember, I am saying y is equal to mod of x. And what is mod of x? It is x when x is positive, and it is minus x when x is negative. Connect the two, remove the y, so remove the middleman. You will get y is equal to x when x is positive. So this line. And or y is equal to minus x when x is negative. That means this line. The slope for this line is 1. The slope for this line is minus 1. Because if you change x by 1 unit, y drops by 1 unit. But if you change your orientation, and I stand here and I say I'm moving in this direction, even right now the slope is 1. I just have to adjust the direction. Now if I move 1 in this direction, y moves 1 up, right? So if you reverse your thinking, there is a slope of 1 in this direction. So I hope that basic introduction makes sense, right? So if I know that, okay, this is the function, this is my input output kind of a table, and I know that I can create that table and plot it on the graph, that itself is a huge mathematical thinking level step. It can solve a lot of problems for you, because now you can start thinking and observing on your own, which we'll do together, but the gates have opened. So just a small memory shot. Mod of x is like so. This is y is equal to x. This is y is equal to minus x. And this is my memory remembrance. It comes to the origin 0, 0, and it goes up. Now, if I ask you, what is the minimum value of this mod function? Let's start building that vocabulary as well, right? What is the minimum value of this function? I know it is 0 because it is coming down up to 0 or down to 0, and then never falling below that and then going up again. So what is the minimum value? 0. What is the maximum value? Infinity. It keeps going up and up. If you put x as 10,000, you will get 10,000. If you put x as minus 10,000, you will get a 10,000, right? So there is no limit to that. But the lowest point is definitely 0, 0. Let me change the story a little bit. Y is equal to mod of x, let's say plus 2. And again, we have done these operations, but just doing out of the board one more time, and this time going a little more slowly, putting the table on the board as well, just in case the first session was a little fast in terms of how quickly we went through it. So mod of x plus 2. So okay, x is 0, y is 2, right? I'm assuming everybody can take that step. X is 1, y is equal to 3. X is 2, y is equal to 4. Good. This should be enough to get me started. This is my coordinate axis. This is my origin point, x axis, y axis. When x is 0, y is 2. So 1 and 2 may be point here. When x is 1 point on the x axis, y becomes 3. So y is 3. When x is 1, y is 3, right? Now I can draw the line because I know it is a linear equation, right? So this will be the line. Or you can try out a few more values. So I'm assuming once you understand the concept, you'll be able to draw it, and then maybe you don't need to draw it and just understand well in terms of the abstraction of the changes in the story, right? Put x is equal to 10, you will get y is equal to 12, right? Because 2 is being added. So you will, when you have x is equal to 10, y will be equal to 12. Now in the other direction, when x is equal to minus 1, when x is equal to minus 1 will become 1 and you will get a 3. You will get a 3 again. So y is equal to 3. So at minus 1 again, this was 3, you get a 3 again, and again you can guess the line will go like this. Now compare your original mod and this function, right? Your original mod was centered at 0, 0. Why do I want to compare it to that? Because that is very easy to remember. Using that, I can come to this point fairly quickly, right? So notice what is happening. The whole graph, this was my original mod graph. The slopes are identical, everything is the same. Everything has moved 2 points up. So this point has moved 2 points up. When x was equal to 1, y was equal to 1. And now it has become 3, it has moved 2 points up. So every point, every being has moved 3 points up. So this is what I want to get visualize and in terms of animation happening in my head, that when I see a plus 2, it's very quick. Okay, I know the mod function is that, and now I have to just lift 2 up. And what does that mean? That means if I just draw a shorthand, I know this point is 0, 2. Because this point was 0, 0, right? It's finally about knowing the points because that's where the game will lie. So it was 0, 0, x was 0, y was 0. Here x is 0 and y is 2. Here x is 1, if I go for there, x is 1, y is 1. Here x is 1, y is 3, right? So I can plot the points. All I know is that everything has shifted 2 up. And I don't need all the points. This is an interesting point. After that, it's a straight line, right? So I can start thinking there. So I hope we understand what happens when there is a plus 2. Now I will not go into so much detail. What if I put a minus 2 here? Again, draw out the table. At x is equal to 0, you will get a minus 2. So let's start drawing it on the same graph. It will get a little cluttery, but we'll see the point, right? So at x is equal to 0, y is equal to minus 2. So 2 points below, this is my minus 2. When you put x is equal to 1, 1 minus 2 will give you a minus 1. This is minus 2. Add 1, you will get a minus 1. Now I can draw the line and I can now guess the function will remain the same. And I hope we get the point that if this is mod of x, right? Mod of x minus 2 means every point has been shifted 2 points below. And here we can start our question, an interesting question. What is the area of this triangle, right? And again, for this I can give you more formal language also about the conditions, but right now it's visible to me that there is a triangle being formed because the mod is coming below the x-axis. So between the mod and the x-axis there is an enclosed region. What is the area of that region, or how many integral solutions lie in that region, etc. That journey we can start. So in this case it was just going up, so this was the only interesting point, that this point is 0, 2. But in this story, not only where it comes down to, but now it is cutting the x-axis at 2 points. So that is also an interesting analysis, because once I get these 2 points, I can find the base and then I can find the area of the triangle, right? Or just for fun, I have seen throughout my journey that these intersection points are very, very interesting. So next I want to think about this story.